Oh, very good evening. Thank you for that. Yeah, so I spent a long time in my career in HSE going to meetings like this and not telling anybody who I was or where I was from. Simply because we find people had a quite a view of HSE and their activities and what they do, and you either get people who wouldn't speak to you or they speak to you an awful lot.
I've got a friend who used to live here. She used to walk her dog and met them. 6 months before she told me what she did.
Yeah.
She went off and safety inspection, check her up. Yeah, still some people.
So, I mean, a few years ago, I decided, well, I go around doing my job, I see a lot of things that we should all know about, I learn a lot of things that industry can know about. There are very, very few accidents that go off that really weren't either foreseeable or before people should know. And I have this slide, I'm a bit scared about some of the things I say because I'm being recorded, but I will be candid with you. Agency frustrates me sometimes a little bit in that it isn't particularly great at disseminating this information. So I've started sticking my head above the parapet a little bit, putting things on the internet. Obviously nothing too case sensitive. And I guess that's kind of why I'm here really, that one or two people have seen the things that I put online and thought, well, I'd be quite interested in what Steve. Now, normally, when I talk to people, they're not as into the industry and as knowledgeable as you people are. I'm normally talking to either health and safety generalists or members of the public even, or new gas engineers and that sort of thing. So I'm a little bit nervous. You're probably going to be bored to death by what I'm going to say for the next hour. As is always the case, the best thing is to ask questions, and let's make it two ways. If I only get halfway through the talk and the hour's up, we can call it this and say we've had a good evening. So, I'm going to talk to you a little bit about what HSE is, where it's come from, what it does and what it doesn't do, and then my role within HSE, how I investigate gas explosions, the sort of things we look for, a couple of case studies that you might find. We're doing an awful lot of work on hydrogen at the moment. I've chosen not to really talk about that because sort of every talk you go to about gas these days is about hydrogen. But if there are any hydrogen related issues you want to speak about, feel free. So, pick me up there. Oh, hey, we fell at the first hurdle. There we go. It's come back to life. It's like a civil servant computer. It's falling asleep. So there's me. My name's Steve. Oh gosh. My name's Steve Critchlow. I have an MSc in gas engineering and a degree in mechanical engineering. I'm a fellow of the Institution of Gas Engineers, where I'm on the membership committee and the council, as well as sitting on various committees such as the Gas Industrial Safe Situations Procedure. And I'm employed as a principal gas engineer at part of HSE called the Science Division, which was previously called the Health and Safety Laboratory, which was previously called that, before that, the Research and Laboratory Services Division of HSE. And I'll explain a little bit about what that is as well. So I'm a gas safe registered engineer. Most of my work is downstream. I'm guessing most of you guys are upstream guys. As I say, a member of IGEM. I'm also Offtech and HETAS qualified because HSE also regulates those industries, but clearly they don't regulate it as much or as closely as they regulate the gas industry. So that's me. And I sort of put a first version of this talk together about 6 months ago when I was asked to give a talk to the local round tables. And some of it was quite basic, and I've stripped a lot of it out and done a little bit for tonight. But I put a few slides in about really why is HSE so interested in gas incidents or in the gas industry. Well, here's a piece of CCTV footage, and if you keep your eye sort of around about here, you can see this domestic property. This was in South Wales about 3 years ago near Port Talbot, neat, really. And that video slightly slowed down. A gas explosion like that normally lasts about a second or a second and a half. But I've slowed it down so people can see it and sort of just visualise quite how horrific it would be to find yourself in the middle of that. Now, that's what the house looked like afterwards. It's one of these houses that looks like a semi-detached but is actually 4 flats. And the lady moves into the first floor flat there. She buys a second-hand gas cooker off Facebook Marketplace and her friend installs it for her. Now, as gas professionals, we sort of go, oh, no. But actually, fixing a gas cooker looks ridiculously simple, doesn't it? And you would think, hose into the bayonet, thing lights, happy days. And of course, the gentleman who did it thought that he was doing her a good turn. But as gas professionals, we know that you have to be registered, and the reason you have to be registered is because that reflects your qualifications, which tell you how to do gas tightness tests, commissioning checks, suitable separation distance and location and ventilation, all those things that we're trained for. Now, what had actually happened here was there's a redundant pipe in the house that had previously been damaged, so it's got an open end under the floor, and a well-meaning guy just connected the gas up that. So he left the cooker operating, but it was pouring gas out through an open end 22mm pipe under the floor. Registered engineers shouldn't have done that. So that's kind of why we have these very descriptive regulations, one of which says the gas safety installation and use regulations, you'll do a tightness test after you've done something that affects the gas tightness.
Well, you know, that last picture, if I'd gone to site, you'll see that house like that, it's so deep, so.
Yeah. Well, you're right. Yeah, I get that as well. You've obviously got to consider where the gas has come from, and a lot of explosions are from remains, but generally speaking, pretty safe territory. You know, it's downstream when we're looking at that. So obviously, most of us are talking about natural gas and mains gas, but I do a lot of bottled gas as well, and I have to say that the worst areas of gas engineering that I deal with is with LPG, bottled gases. Not because there's anything fundamentally wrong with that industry or that fuel, it's just that people do things with those fuels. They dream of doing with a gas installation, I don't know why. So a few years ago we had a rather horrific explosion in Walsingham in County Durham. This is a guy who's involved in metalwork, so he's got bottled gases in the back of his van with hoses connected to a torch, and all our regulations say that that van will be heavily ventilated so any gas leaks can get away, that you'll disconnect your hoses at the end of the day, turn off the cylinder. It's not what people do, and he's had a gas leak in his unventilated van. He's about 20 yards away from home, having set off in the morning when he hits his indicator, boom, the van goes bang. So obviously part of my work is to investigate what's gone off, that's great, but HSE really, if it's going to fulfill its remit, has to then sort of say, gosh, this is an issue, we need to learn from this is tragic. So some of the work that I did at the laboratory was to do recreation videos, not really to show what's happened, but to put some graphical information out there on the internet to tell people about the importance of carrying your bottled gases in a safe way. So again, that's a slow motion video of a test we did at Buxton at the Science Division. Buxton, if you've not been to the Science Division there, it's a 550 acre site in the middle of the Peak District. And it's there simply because we do things like that, so we have to not just get the neighbours too much. Again, so yeah, when you see it, now if you're a van driver or you are somebody who's carrying around bottled gases, a video like that is worth so much more than me wagging my finger at you saying you must have a ventilator fan and you must disconnect the hoses, because health and safety's gone mad, hasn't it? And yeah, what do the men in suits know? Well, yeah, there's always a reason why regulations say what they say. And last week I was speaking to somebody about regulation, and I made the point that I think in nearly all cases in this country, particularly with health and safety, our regulations are retrospective. They can look onerous and a bit stiff-collared, but we only ever really regulate in this country when something's gone wrong and we think we've got to avoid it. That's the case in point. Now, here we've got a wagon. This is a tarmac wagon, and when I say that, I mean it's Tarmac Adam, it's not the company Tarmac. And this is not an untypical arrangement. What we've got is a hopper on the back where the hot tarmac from the quarry is delivered. The lorry's job is to get it to the site where it's going to be used and it's to keep it warm. So we've got LPG cylinders on the back, and we've got a sort of 2.5 metre long ribbon burner in that little 6-inch envelope underneath operating. Okay. Now, so we've got our LPG cylinders completely unsecured on the back of the van. There they are. The keen ones, you'll notice there's no regulator, so we're taking LPG off at about 7 bar through a long hose that goes into the back of there. And the system of work is that the gentleman has to jump on the back of the wagon, turn the gas on, and has to jump off the back of the wagon, run around the back, light a taper, put his arm and head into there to light the burner. So question number one, I'll go to the gentleman with a beard at the back, what's going to happen? Yeah, and you can see that, and I can see that, but presumably the person who put this system together couldn't see that, and they can't see it now because they're facing it. Now, so this is, again, management of health and safety at work. Regulation says you will plan and risk assess the job that you're doing. And it says it for things like that. If somebody sat for just a moment and thought of it, it's perfectly obvious what's going to happen. So again, what happens is the phone rings, the voice on the end of the phone says, Steve, we've had an explosion, somebody's very badly injured with life-threatening injuries, come and have a look. I get myself off down on the motorway, find this, I'll look at it, it's all straightforward. You write a report about what's happened, but then you have to give an opinion about the foreseeable nature of it, the shortcomings of this design and what was fundamentally wrong with it. So as part of that, again, I'm going to what I've done is roughly work out how long it takes to get on the back of the lorry, get around back and you might get away with it 10% for one day, you little actually, so our laws require us to plan the work that we're doing to avoid that sort of thing. So they've been examples of gas engineering. Obviously, the other big risk with gas is carbon monoxide poisoning. Now, I would say, if I was entirely honest, that natural gas related carbon monoxide poisonings are pretty rare. Certainly fatal ones are now. They're not exactly a legacy issue, but we don't kill very many people with CO, and that's largely because of the design of modern appliances. But I will say that every single carbon monoxide poisoning is avoidable, completely unnecessary and tragic. And I was at a fatal carbon monoxide poisoning yesterday in Croydon from a modern room seal Leyland boiler. So they do still happen. And the picture, the news item I've got from there is something you may be familiar with. So in 2009, I was called to a double fatality of 2 gentlemen in a place called Saltash near Plymouth. And what I found when I got there was that there was a Beko cooker installed in the kitchen. The gents had come home in the evening, they bought a pie and they put it in the oven, turned the grill on. And because of a design flaw on that cooker, it was allowed to operate with the door shut, which formed full seal, so it starved of oxygen. And it produced fatal levels of carbon monoxide. Now that was a CE-marked appliance that had been designed and manufactured and gone through its testing. It shouldn't have been able to do that, but it did. And that appliance ultimately killed about 16 people throughout the UK and Northern Ireland. And there's been inquests, there's been product recalls, there's been safety bulletins that have gone out. And then this year, in about May, I was called to a house, again in Croydon, funnily enough, where a lady died, and I went into the kitchen and I found a gas cooker manufactured by Glendimplex, not a Beko, but the same manufacturer, and it had got that same design flaw. And that cooker was built in 2016, long after we'd known about this issue. So it's something we have to be mindful about. The biggest issue with carbon monoxide is from petrol engines, oil engines. So I'm not going to go on about that now, but if you ever work with a petrol generator, you'll probably know a modern gas appliance will probably produce about 200 parts per million in flue. Petrol generator, if you measure its flue, will measure about 50,000 parts per million. Not because of the defect, but because it burns fuel rich. That's what it does. So always in fresh air, out in the open. So let's look at HSE. Who are HSE? We've all heard of the Health and Safety Executive. So the Health and Safety Executive is actually part of government, and that means all its employees are civil servants. And that means they're all bound by civil service rules. That mean we limit our commercial activity and bind us to things like the Official Secrets Act. Now, the Health and Safety Executive was created in 1975 by the Roberts Report. And from the 1830s, there had been various Factories Acts and the Child Labour Act and things in the UK to try and improve the conditions of the working environment for people. And various inspectorates have grown up. So we had inspectors of mines, inspectors of quarries, inspectors of factories, etc., etc. And in 1975, after a whole series of accidents and a big review of health and safety in the UK by Lord Robens, Health and Safety Executive was created to put all those inspectorates all together in one lump. One of the big drivers was the accident that happened at the early 70s, big explosion. So the Health and Safety at Work Act, etc. in 1974 was written, which is a very broad, sweet piece of legislation. And if I was to summarise it, it basically says you as a business, you as an employer, will not do anything to put your employees or members of the public at risk. It basically says you will work in a safe way. That's what the Act is, very broad brush. And the Health and Safety Executive was created to regulate the Act. In essence, that's what it does. So we can do stuff that the Act requires, and we can't do stuff that's not in the Act. So, if Clinton here is climbing across his roof at work, doing something very dangerous without edge protection, a health and safety executive person can come along and tell you to stop it, tell you to work safe. If you're doing it at home, on your own home, do it, because it's not under the health and safety work. And, again, that's something that I have people berating me on social media saying, why doesn't HSE do something about this? Well, HSE can only do stuff that's in the Act. That's just how it is. So, for instance, we can't do anything about trading laws, for example. So, within the HSE, you can, obviously it's more complicated than this, but you can broadly think of it as three separate, distinct bits. We have the inspectorate. They're the people that go out into factories and workplaces and proactively investigate, or inspect rather, to see how you're working. And for gas, if you're an upstream person, that's our energy division inspectors. And if you're a downstream engineer like me, that's our field inspectors. We have a research and forensics capability, which is largely dealt with by the science division, which is where I live. And they're involved in carrying out scientific research to allow us to create new legislation or test products or ensure what's safe, and forensic investigation trying to find out what's gone wrong. And then we have a sort of policy people. Now they're the people that are involved in talking to the public generally, talking to factory owners and workers in broad brush policy stuff. Now, in terms of gas, The policy people are the people that hold the contract with the gas safe register. So, Regulation 3 of the Gas Safe Installation and Use Regulation says, if you are a business doing gas work, you will be gas safe registered. Okay, and what, it doesn't say that actually, it says you will be a member of a person's approved for doing gas work by the Health and Safety Executive. And what that means is you'll be gas safe registered. The register belongs to HSE. It's our register, but we have a contract with a company called Capita to run it on our behalf. And they run it for 5 years, and then the contract gets renewed or goes out of bid. And you'll be aware that for many years that was run by Corgi, and so people became aware to ask for Corgi registered installers. 2009, Capita won that contract, so HSE created the name the Gas Safe Register. That name belongs to HSE, Capita run it on our behalf. So the policy people deal with Gas Safe Register, and then obviously I link in with those quite closely. Right, excuse me. So, I've mentioned the Health and Safety at Work Act and what that is, and HSE's role in that. One of the things that the Health and Safety at Work Act does is give HSE the right in law to propose legislation, secondary legislation. So I've put on the screen there 3 main pieces of law that gas engineers and people in gas businesses deal with. So downstream we're talking about gas safety installation and use, and then we've got pipeline safety regs and gas safety management regs. They are all pieces of legislation proposed by HSE, written under the Act. That's where they come from. So HSE doesn't sort of write them, but we are obliged by the Act to talk to industry, gather information, and put forward proposals to the minister for them to sign off. So again, they are HSE's legislation. Right, so investigating a gas explosion. So that's kind of what most people think that I do. I actually spend quite a bit of time doing that, but it's not what I do. The first lesson about investigating gas explosions is that buildings and plant explode for lots of reasons. And the media are great at sort of saying everything that goes bang is a gas explosion, but there are lots and lots of reasons. And I've got to be able to tell the difference between a gas explosion and a bomb, for example, and be able to then carry on my investigation and say, yes, it's a gas explosion, right, where did the gas come from, why was the gas released? So we can think of overpressurization, so things like steam, can be a steam release, or a failure of a pressure vessel can cause a plant to go down, nothing to do with gas. Solvents and vapours, so somebody put petrol on the floor and lit the flammables, or spilt some sort of accelerant. Explosives seem to be increasingly common. So what I've got a video here. I said a few moments ago that I actually be able to distinguish a gas explosion from other types of bangs. So understanding how a gas explosion develops is kind of key to that, really. So what we start with is an enclosure that's full of a gas and air mixture. Ignition takes place at a particular point in that gas and air mixture, and the flame from that point then burns out in all directions, omnidirectionally. So you end up with what looks like an expanding ball. You've got a very, very narrow band of flame as it's burning through the unburnt mixture, and behind that are the hot products of combustion that they're expanding, and they are driving that flame forward. and a speed known as the burning velocity. And in front of that flame front, we've basically got a patch of air that's being compressed as the flame front moves forward. That's the pressure wave. So the pressure wave, compression is in front of the flame front, and the flame front is travelling pretty quickly. So typically we quote about 4.5 meters a second for the burning velocity for natural gas, but that depends on concentration. And what that happens then is the structure that's containing the gas is pressurized in all directions at the same time. So if you assume that the vessel is of equal strength, it will fail in all directions. And that gives you a very distinct pattern of damage when you compare it to something like a higher order explosive, which will be very directional. Now, the last thing you saw in the video was a weaker panel, hot house. Now, if that's your house, that was once upon a time, that would be the window. The single glazed windows were always very weak and would often save a building failing. Nowadays, we've got toughened double glazing, which is much stronger if it's fitted properly. And that often, because that resists the gas explosion, that causes the whole house to explode. If we're talking about industrial plant should have weak panels built into it, explosion panels. And the idea is that once we get, that pressure is developing, but the pressure that we get is entirely dependent on how much we resist it. So in other words, if we had a gas explosion outside in the open air, we'd get no pressure at all. It'd just be a little bit of wind. When we're in a structure, as it goes against it, it's passing, and then when it gets to the wall, that's when it pushes and we go up pressure. So natural gas can create up to 8 bar pressure in an explosion, but typically it'll be about 100 millibar, not very much at all. Again, in terms of explosives, gas isn't that much, you know. So if we can get that one sacrificial panel to fail preferentially, we can save the structure. Now I've said a few words about it, let's have a look back and see if we can watch it again, if that makes a bit more sense. That's a sort of real-time explosion, destructive and quite scary. You can see that flame. So the actual flame is very narrow, right on the outside of that ball. If you watch from outside, you'll see that the panel moves out, and it seems as though actually the flame is somewhat behind it. And there's a second explosion takes place when it comes outside, because it's suddenly got a new supply of oxygen. So that's a bit like hitting the turbo. So all of that gives me an indication. We've got a couple of slides there which sort of show it developing. It starts to exert pressure. Now, if the structure is able to resist it, the pressure continues to build until, so we can see that there, as the structure starts to fail, we get a peak. Then we have a particular bit of negative pressure, which is called backdraft. That's where part of the structure will actually suck in, and we come away from that. Now, in terms of our gases, natural gas, as we know, is lighter than air. So typically, when we release it, it will form a layer above the release zone, and LPG is heavier than air, so when we release it, it will form a puddle on the floor. And that's important as well. When I ignite it, it's going to burn where the gas is, and it will leave patterns of burning up where the gas has been. That's a marker that I look for that tells me where the gas has come from and what sort of gas it is. And I've put a thing there, so consider a single alcohol burning a cubic 1.5 kilowatts gas rate. This releases about 0.14 meters cubed of gas an hour. Can this create a flammable atmosphere in a large kitchen with one air change an hour? No. And that's why we have permissible leaks, basically, when we're looking at sort of downstream gas tightness tests, because we accept that some old appliances will leak a little bit, and we've got to get up to 5% gas in air before we can have a gas explosion with natural gas, 2% gas in air with LPG. So all gas leaks have potential to be dangerous, of course. Very small gas leaks you're not going to get there, particularly if we have ventilation. So, this is one of my, for want of a better expression, one of my favourite gas explosions I ever went to. This was a place called Llanhaven in Wales, probably about 10 years ago now. And again, it was one of these houses with a flat downstairs and a flat upstairs. And there was a bang. The guy in the house got quite badly burned, superficially. The windows popped out. The emergency services have come and have taken him away to hospital. But it transpires that this family that live in this house is one of those families that are, let's say, known to the police. Police around there most Saturday nights. And it never occurred to them that there'd been a gas explosion. They just went, oh, it's gone now. And it was only a couple of hours later when the people upstairs rang up and went, there's a blue flame coming through my wall, that they actually thought, and that was a pipe in the road that had failed. So that had got its way into the cavity. Now, the point really about the slide is, can you see that the windows have gone out? But if you look on the mantelpiece and you look on the table here, there are papers there that haven't moved. And that's really important about illustrating this point about the gas, as it explodes, relative to other explosives, it's moving very slow. And the pressure that it builds up is entirely dependent on how much we resist it. So because that window was very weak and quite large, the pressure is dispersed really quickly, to the extent that it hasn't really caused any damage. What we've got here, this is a house, I don't know if you can make that out on the overhead, but this is from a house in Edinburgh where there was an elderly lady who was nearly blind, and she'd left her cooker pots going for quite some time, and then there was a bang. Now what we've got here is painted wallpaper. That's where the cooker has been, and I don't know if you can make that out, but the wallpaper is scorched, like, immediately above the level of the cooker and not below it. And again, that's that marker that I was talking about. The gas, because it's lighter than air, will accumulate a mix in the air above the release point. And then when we ignite it, that fast-moving flame front will cause some very light thermal marking on susceptible surfaces. So by that I mean light plastics and oil-based paints. That's a really key piece of evidence for me. I'm looking for where the scorching is and where it isn't. And that's really as textbook as you could get, showing me the gas has come from something that's at exactly the height of the cooker burns and not any lower. Very key aspect about what happens in a gas explosion, not always, but usually, is that after we've had that event we saw on the video, there's a brief, very brief period of time when the gas goes, or the flame goes, and it burns back to the source of where the gas is coming from. Now the flame in an explosion normally goes out because we've either used all the gas up or we've used all the oxygen up. Right at the end, there's still a source of gas from the leak, and if it can get air, it'll burn there very locally. And that creates some very localized deep burning just around the source. So what we can see here, this is taken from a house in East Anglia, Barnsley, I think, that exploded on Christmas Day. And I had to get myself down there. And the story was actually that a new boiler put in on Christmas Eve, and the guy had not tightened up the ankle and got TCB, done his tightness test like Dave, but had done it where the regulator had locked up, so he hadn't tested here. And that scorching there around the regulator and the melting of the gas directional label on the anaconda is showing me where the flame has burned back to. So it's a visual marker about where the leak source is. And what we can see here is this is a house that was being, this used to be a kitchen, big house outside Grimsby, and it's got LPG on a bulk tank outside. It used to be a kitchen, there's a plumber in there, converted it to be a dining room, so taking all the appliances out. What he's actually done is put a chisel through the floor and punctured the a gas pipe in the floor, and it's leaking through the concrete and coming up through the sides of the floor concrete. So if you look there, I don't know if you can see scorch marks again at floor level. It's that visual indication of where the fuel is coming from, where it's burned back. And because of that very low level, that's telling me it's LPG and it's at floor level. So this was quite interesting for a number of reasons. It was on a Saturday. I took a call on a Saturday morning, and it said there's been an explosion in Grimsby. Kind of trying to light this fire and the house has gone bang. Can you go? And I remember distinctly saying to my wife, I can only be on the tiny terrace in Grimsby. I'll be there about 2 hours. I'll be back for this afternoon. And I got there, and this was the biggest house in the world. It was absolutely enormous, and about 50 acres of its own land. And yeah, so I didn't get back for 2 in the morning. It was about 2 in the morning rather than 2 in the afternoon when I got home. So it was a big investigation. The other thing that stuck in my mind about this was that the actual ignition source was the guy in the house had smelled gas, and he walked into the room with a cigarette lighter. Now, I've spoken to people about this, and they go, well, what sort of idiot would do that? But it's just the nature of accidents. This was actually a really clever guy. He was an offshore electrician on oil rigs. Very educated, very clever. Just had a momentary, there's no light switches in there because the room's being renovated, and he got his cigar lighter. And we all do things like that, really, momentarily. Here we've got a house in Accrington. It's Accrington, and again, you can see the state of it. The gable wall has come out completely. Roof is tainted. Round the back of the house is similar. This house had to be demolished, and I was called out to this as a gas explosion, and you can see why. Huge bang. People are very badly burned. The house is destroyed. Steve, it's a gas explosion. So I'm looking for all that evidence that we're talking about, and we can see we've got an omnidirectional pattern of structural damage. We've got things being dispersed. We've got burns. What we haven't got is any sort of evidence of any flame front in there at all, and that's because this is a steam explosion. It's that there is where the area coming on the landing used to be. It's got a copper cylinder. Used to have 2 expansion tanks in the loft. Plumbers in there converted it to a sealed system. Just want to use the loft for something else. Doesn't know what he's doing. So there's no expansion facility on the tank, on the cylinder. The immersion heater fails. Off it runs. Fine. So I'm sure you probably know this. It's just basic thermodynamics, but it takes an awful lot of energy to make liquid water transition to steam. And that means that steam has got a lot of energy in it. It's why we use it for so many industrial properties. When we put that energy in to make a phase transfer, to transfer liquid water to steam, that happens at 100 degrees, doesn't it, at atmospheric pressure. And the water expands about 1,600 times because of the amount of energy it forces the molecules apart. But if you can keep that water inside an enclosed vessel and stop it from expanding, all that energy is then contained in the steam. And what we find is that whilst we're in this sealed vessel, we get water at 100 degrees, we get water at 110 degrees, 120 degrees, 130 degrees. It's still liquid, because it can't turn to steam, it can't expand, so it's superheated at 140 degrees, all the time exerting more and more pressure on the cylinder until the cylinder does have enough pressure for it to fail, it cracks. And then instantaneously, you go to atmospheric pressure and it flashes to steam. So in other words, you've got a rapid transition from this, say 1 cubic metre of water to 1,600 cubic metres of steam. It's an explosion, but it hasn't got the flame front. That's the marker that I'm looking for. So you can see the level of damage that it's able to do. And this was a real near miss. That was the airing cupboard. The room next to it was the baby's nursery. And it just so happened that that evening baby was crying an awful lot and went into the bedroom with mum and dad. Dad went into the sleep in the nursery to make room for the baby, and he lost basically all the flesh on his legs as a result of that. But it would kill the child without a doubt. And that's again incompetent workmanship, obviously. The family rang up the plumber at tea time and said, we've got steam coming out of our taps. And he said, well, turn the boiler off, I'll come round in the morning. Of course, it's nothing to do with the boiler. And so, investigation and prosecution. Another explosion that I get called to, again, you can see why. This is a fatal. It's a chip shop in Hull. Huge damage. Difference here is that the incident has prolonged burning after it. It's very smoky. As I do my investigation, you get a deep pattern of burning on the floor, which is not something you get with gas explosion. And this is an arson attempt using petrol. So liquid fuel goes on the floor, it's giving up its vapor, and you light the vapor. So that vapor ignites and it expands in exactly the same way as LPG or gas will. So you get a flame front, you get the expansion omnidirectionally. The difference that you get is that secondary burning of the floor. So that's the marker again that I look for at that. And here is the third example of an explosion that's not a gas explosion. There's a house in Stockhill Lane in Nottingham that I went to. A council property, new boiler installed that week. What's a gas explosion soon, doesn't it? Come along. And the first thing that I did when I got there was meet with the fire service, who talked to me about the injuries of the people in the house. And mum and dad downstairs had lost their eyes had exploded. They'd lost their hearing because their eardrums had exploded. I can't remember the specifics, but they lost limbs. I think the dad had lost both arms and both legs, and the mum had lost one of each or something like that. Really, really bad. That's not a gas explosion. The extent of the pressure injuries that they've seen is far in excess of what a gas explosion would do. That's the key marker. Now they were downstairs, kids were upstairs, and basically the kids just sort of rolled out of the bedroom and landed on a pile of rubble and went, what's that? And they were completely unheard, really. Now, so that's the back of the house. The front of the house travelled about 100 metres across the fuel carriageway. So you can see from what I've already said that actually it's not fitting with a gas explosion. Even though it's a domestic property that's gone bang, the difference between the front of the house and the back of the house in terms of pressure distribution doesn't fit with a gas explosion. The injuries that the people exhibited didn't. And then they were messing about with high explosives, TNT really, in the washing machine. So, it was, I mean, at that point, obviously that's no longer got anything to do with HSE, so you step away. But one of the things that I remember from this explosion, was that this was a really, really hot day in the summer, really, really hot. A little bit like the summer that we've just had, in sort of late 30s, mid-30s, early 30s. And when I was going through this washing machine that blown to bits, it had got a big black balaclava in it, it had got a black woolly jumper, a black overcoat, black gloves, and I'm thinking, this guy's been up to something, and of course he had. So, putting all that together, here's an explosion that I investigated in 2016, and it shows you a little bit more about how HSE works as a whole. Some of you may well have been involved in this. This was in Yorkshire, a place called Haxby, just outside York. So there was an explosion at 7:15 in the morning as a gentleman got up. Many gas explosions occur at that sort of time, purely because the gas is able to accumulate overnight and get ignited when the person wakes up. The gentleman who lived in the house died as a result of the explosion, very sadly. And at the time, later that morning, I was actually driving down the M1 towards Northampton, and I took a call from his office who said, you've got to go to this, I have to turn around. And when I got there, it was an incredible scene, actually, because there was so many police there. The counter-terrorism squad were there, the bomb disposal squad were there, And they were there simply because somebody from the gas network had went, oh, it's too big, it's not a gas explosion, this. Without any real knowledge of what a gas explosion is, it's just like it's a big bang, it can't be gas. Now, in the way of that house in Wales I was showing you about, gas explosions can be very small. In the right circumstances, they can also be very large. And that really means when we get gas that goes right through a multi-room property. So if we've got gas in a cube, it behaves exactly like that experiment that I did. But if we put it in 4 interconnected rooms, we get an acceleration effect where the gas gets faster and faster and faster and get a really big bang. So we got damage to other properties over about 100 metres area. Now you can see that. Really, there's no two ways about it. It's a really big, horrific, destructive bang. But the first thing I'm sure you'll be looking at now, straight away, that omnidirectional pattern of damage. That's not what you get with a bomb. That's what you get when you ignite a vapour or a gas cloud so that the pressure is going in all directions simultaneously. So I'm able to look at this and go, well, it looks like a gas explosion to me, and everybody else calmed down. We were able to get on with the job. But all of these houses around here have all got missing tiles and broken windows, and there's a church window a long, long way away that was broken. There's me in the middle there. What we've got here, where I'm stood, is the dining room of the house, and then we've got the kitchen of the house, and that's the door frame that used to go between the two. Can you see the bottom of the door frame, that very localised burning at the top of the wood? Now I see that and I think, well, you know, doesn't prove anything in its own right, but that looks to me like that flashback that we discussed earlier. There's been a big explosion, there's been a big flame drop, but there we've got that very localised pattern of deep burning. So after doing the investigation, I'm able to model a picture of the house. We've got the gas network, service pipes in. Obviously, there's a whole tranche of work that takes place before we even start on the house with the gas network, checking the main in the road and the service pipes to all the local properties. And we would, generally speaking, try and do that first, and get that ruled out if we can. Once we can get access to the ECB, we can cap off the network, rule that out. Again, that gets the whole bunch of work out of the way. So the gas meters at the back, we've got a very old boiler and a cooker, and then there's a buried pipe in the floor going through to where the gas fire is. And all the time when I'm going through the rubble, I'm looking for where scorching is, and you find lots and lots of scorching, but interestingly, there's lots of scorching at floor level of the carpet, which is not necessarily something I expect to see gas or natural gas explosions, depending on where the leak source is. So you get an idea of where the installation is, where the gas pipes are, having already decided it looks a bit like a gas explosion. And by a series of tightness tests, I can see that there is a leak on this pipe here in the concrete floor. So the last thing I want to do at that point is just stick that pipe up, because I'm dealing with evidence. And if I get my chisel out, the defendant down the line is going to say, you damaged that gas pipe, Steve. So that's, we've put a boroscope up the pipe, and we're able to examine non-destructively and see there is a separation in this pipe. And the separation is there on that door frame. So that's when I'm able to chisel it then very carefully. And what I found was this here. Okay, so we've got a 15mm copper pipe that's buried in the concrete floor, and it's got a full separation in it sort of diagonally. So I'm going to ask a question, and there isn't a right and wrong answer, but I'll come to you at the back there, if you don't mind. Looking at that, what do you think's caused that? Yeah. And to be honest with you, I was on site, there was a couple of other insurance investigators there, and we thought that was the most likely thing. Well, I'll come back to it, but we actually thought that was probably cut by a still saw, and that it was therefore probably almost certainly been done when the house was built 20 years before, and they'd buried it in the concrete, and it's just over time it's been able to get out. So at this point, we're thinking, right, we're going to have a problem here identifying who did that, but we're going to have to try, because that's really serious. And I think that's a legitimate thing to say, looking at it. But when you take it back to the laboratory and properly under the microscope, again, that's not cool. And that's such an important point about never jumping into conclusions when you see something, getting the right people with the right qualifications to have a look at it. Now, the metallurgist has got this at the laboratory, and metallurgists are a particular sort of people, very excited by this, because copper, as we know, is very malleable, and this has failed in shear. What that means is, if you take a sort of brittle material like cast iron, it will shear, snap like a stick of rock, if you like, whereas, or a carrot, whereas copper should sort of bend like a stick of soft coffee. And this was copper that has failed in shear. And the reason that it's done that is because it's buried in concrete. So the way that we used to build houses, as you know, is we build footings and we build walls, and then we pour concrete in between for each individual room for the floor. Nowadays, when we build them, we put a solid concrete pad across and build upwards. So what this meant was that actually there was two concrete pours right next to each other between the living room and the kitchen. And as there'd been settlement or movement, which we think was probably due to just flooding in York, the amount of water, basically as the floors have done that ever so slightly, snapped the piping off. That's what caused it, with very serious consequences. So that's the investigation of it.
Excuse me, is it properly weakened by the chemicals in the cement? One shear?
Yeah, absolutely. So again, we do chemical analysis on it, and we have a look at it with
You can
electrons.
see the colour where it's going
Exactly.
green, that's the chemical erosion.
It is, yeah. So we had a look at it. There was corrosion on it, but it hadn't lost an awful lot of metal, but it had lost some. So it's weakened it, made it more likely to snap. Interestingly, there was an ant's nest near there, and they apparently emit folic acid, I think, when they weep, and that's very corrosive to copper as well. But the point was, it wasn't a working activity, but we're not allowed to install copper like that on modern houses. As well as doing the floors differently, we would always put it in a thin screen, so if there is any settlement, the pipe would just pop out the screen. This was buried in the concrete, which again, our standards don't allow us to do it anymore. So once we've learned that, what are we going to do about it? The question that I've got to face then is, there's 200 houses on this estate, all built in the same way, at the same age, with gas pipes in the same condition. Do I tell everybody about this so they can make an informed decision, or live in the right panic and value their houses? Or do I say, well, look, gas explosions are incredibly rare. This mode of failure has never happened before, so it's even rarer. Is it worth worrying everybody? And that's not really a decision for me. So that's when I get together with our policy people in HSE and we decide what are we going to do. And what we essentially concluded is, no, we can't sit on this. We can reassure people that gas explosions are really rare, and we've never come across this particular mode of failure before. Typically we have one fatal gas explosion a year, which is far too many, but if you think of 23 million gas installations or something like that, one fatal explosion.
I was in your situation, I can sleep.
Yeah.
Thinking that, say next week another house blew up, that was I did that.
Yeah.
Because you did.
Yeah.
Because you didn't tell them.
Exactly. That was very much my view. I thought, well, you know, yeah, that was very much my view. I think the worry that you would have about it happening again, and we knew about it, was too much. But this is the sort of conversations we have to have in HSE, because what we did, we decided we were going to tell people, We engaged with Gas Safe Register as well, and HSE and Gas Safe Register went to a public meeting with all the people to explain the risk to them. Gas Safe Register spoke to all the registered engineers in the area to tell them what happened, so that if they got inquiries from the public, they knew what to do.
Can you rerun the gas in the public?
Yeah, that's basically what the advice was to do. But if it's their house, it's their responsibility. They have to make that decision. We can help them. Yeah, that's it really. Run it above ground, or.
Did you find any houses that were identical? Sorry.
So again.
Did you find any houses that were laid identical?
Yeah, loads. Basically, they were all built like that. They were 20 years old, so some had been changed already. The majority were like that. But what was interesting to me, in a way, is that people were irate. They were really upset when we were telling them because of the effect it was having on their property prices. They weren't at all happy grateful.
Would you rather go and be open for Oldie when the house is back in place? Because the chances are.
Oh, I know, there's nothing like that focus there.
I know, yeah.
So that is how it was.
So interestingly, it's a proper internals in concrete, corroding and leaking.
Yeah.
Has been an issue since I started in '82. Going on skateboard and cutting out tracing and condemning that stuff.
Yeah.
So it's interesting that it was a fatality. So how do you, have the HSE information about corrosion?
So what we did here is we had to trawl back through all the standards at the time to see if the builder was negligent. We found out that's how you put them in.
That's how it was.
Yeah. Nowadays, first it has to go in the screed. Secondly, it has to be protected. So
Yeah, you have to go on computer lens or
so yeah, so standards. So that from that point of view, there isn't a deal of learning. The industry's already moved on, but it's. Do we then sort of put national warnings out to everybody that's got a house that's 20 years old? And they didn't go down that line. They decided actually,
that's an inherent risk of a known issue.
yeah. But I'm not disagreeing with you at all because I'm interested in gas safety above everything else. But in terms of risk, you get in your car in the morning, you walk down the road, you have one fatal gas explosion a year, and of that one, this is the only time this has ever happened. So you have to sort of make an educated, where you're going to put priorities.
As a result of this investigation, you would then speak to other colleagues and you would change building regs.
Building regs are not HSEs.
No,
yes, you absolutely.
The government, different departments.
Yes.
Say, look, this is the situation. You can't have to be built like this anymore.
That's exactly right.
And you're friends with eventually after 5 years with us.
I think that's the point, really, with the structure of HSE and the idea. I would learn something from doing an investigation. Then we have that policy team, and it's their job to go and here's some information. You need to go and decide what we're going to do about this, and speaking to government and certain
Occasionally, when I read that, you go back to the manufacturer and say.
Yeah. So, for example, the Becco Cookers thing, again, HSE would speak to the coroners, would speak to trading standards, and decide, let's get this thing recalled, let's make sure we're happy with it. Yeah. So you can see how all the things that I talked about helped me decide what the cause was, and then, as I say, we brought it back and used the skills of the laboratory to conclude it, and then from then, we were able to talk to the wider HSE, try and get to that conclusion. Now, on the other tack, here's a double carbon monoxide. This was in 2019, 2018. This is a hotel in central London. 2 Spanish tourists died. So that opening window there goes into the bedroom where the 2 tourists were found dead. And what we've got here is what people call a live well. I don't know if the photo really captures it, but you see my feet there. So I'm stood on the surface at ground level. That thing goes down about 3 meters, and this is about 2 meters by about 1.5 meters. A really small enclosed area with no possibility of there being much of a through flow of air We've got an open window there. We've also got an opening into the bathroom where the vent is, and we've got 1, 2, 3 boiler flues terminated in that area. Room seal boilers. There's the one in the middle. That's got nothing on it. That's pushing straight out. This one's got a plume management kit on it, taking it out. And interestingly, this one, somebody's thought to put a plume management kit on it, but not far enough to actually get it out of the line. Well, really confused about the thought process there. So I'm looking at the installation. It's fairly obvious that the carbon monoxide has come from one of these boilers. And in the room there, that's a plant room, there's actually about 5 or 6 domestic sized boilers all installed in the plant room for this hotel. Now the problem here is, not only are the combustion products from there going to go directly into the bedroom, but the combustion products from there are going to come out, accumulate in the light well, and then go back into the boiler, displacing the oxygen, vitiating the combustion. So you're going to get very high levels of combustion products being emitted that are then going in there. It's not just sucking on the flue, but you're sucking on a flue that's emitting very high levels of carbon monoxide. And these have been put in by registered gas engineers and inspected by registered gas engineers, which is crazy, really. So it's a relatively simple job to go to site and be able to turn the boilers on and test the carbon monoxide in the flue and go, oh yeah, it's producing 1,000 parts. But doing it safely is very difficult, and doing it in a way that captures all the evidence that you would need for a prosecution is very difficult. So what we did here is, as I say, I went to site, each of the boilers was run singularly, and we identified that one there with the half-length PMK on it was emitting 100,000 parts per million of carbon monoxide. So, why is it doing that? Well, the possibility is that it's to do with the fluid deficiency. There might be something else wrong with it. So what we're able to do then, having got all the evidence from the site, and why I mean that is not just having given the combustion product levels, but the distances from the flue to the window, the place dimensions of the light well, all of which paint a picture of the extent of the negligence of the gas engineers who worked on this. And we took it back to the laboratory to do some more work in a controlled situation. So essentially, having made very, very detailed measurements of the boiler and its configuration and size, including the pipework and the pipework lengths and the geometry of the flue, and rebuilt all of that at the laboratory with the flue exactly the same, but not in a light well, so it wasn't breathing in its own combustion products. And we fired it up, I don't know if you can see the screens there, but that analyzer is showing 10.9% carbon monoxide. That's 109,000 parts per million. Now you're upstream, guys, so I don't know if that means a very lot to you, but this boiler should produce about 200 ppm, and it's emitting 100,000 ppm. Those are the sorts of figures that, if that passes into a room, that's killing people really, really quickly. And what we've learned from that is actually, although that flue arrangement is ludicrous, it's not the flue arrangement itself that's caused the boiler to burn badly. The flue arrangement and its location has caused the combustion products to go into the bedroom, of course. So there's something else. And what we find is that the air gas ratio valve in the boiler has been tweaked with. Now what this does, a modern boiler has an air gas ratio valve in it that means we don't need all the excess air that we used to have with old boilers. We can much more finely tune the amount of oxygen to make the combustion more efficient, which is a good thing. But it means that actually, if anything goes wrong, it hasn't got that safety net of the excess air that the old boilers used to have. Now, what we've got to bear in mind is here that we're not just finding out what's gone wrong, but we're trying to capture evidence that would allow us to put somebody in court for killing somebody. So we can't jump to conclusions. You can see these things, because the manufacturers don't want us as gas engineers to alter these gas valves, they seal them with red paint. And you can see that the red paint's flaked off. So you can write your report and go, oh, somebody's altered the gas valve. But when you look at the boiler as a whole, actually, because it's been breathing its own combustion products in, which are acidic for so long, lots and lots of things in the boiler are heavily corroded. And it is possible that that paint's fallen off because of that. So at the laboratory at Buxton, we've got some incredibly talented and clever photographers. And they use a particular technique on this, where they take, I think, 12 different photographs of that valve at different focal lengths, and then put them all together to give me as much information about that as you can get. So what we can see is we've got a screwdriver mark there, and a screwdriver mark there, and just some little shavings of the brass there, where somebody's been altering that offset there. So that's basically altering the gas and air mixture that's going into the boiler, making it very gas rich when it modulates down to its low rate. So that gas valve has been altered by somebody. I would imagine the reason they've done it is because the boiler's burning very badly because of the flue arrangement, so they're trying to tweak it about in competent work. And that's the reason why the boiler was producing 100,000 parts per million. We don't want to destroy this evidence that we've got, so we don't want to take the gas valve to bits. So again, at the laboratory, we're able to then X-ray it. And what we can see here, this is our offset pin on the offset valve. And the X-ray shows this one, this incident valve, has been turned in. I'm coming to the end, aren't I? So so as well as doing incident work, a very, very important part of my job that takes up increasingly large amounts of time is this thing called expert evidence. Now, expert evidence is most witnesses that go to court are referred to as witnesses of fact. So, if you attended an incident in your job and the court asked you to come, you'd be expected to go, yes, I arrived at 7 o'clock, this is what I saw, this is what I did, these are the measurements that I took. You're not expected to give any opinion. An expert in court is appointed to assist the court, and it's a unique role in that you are allowed to give your opinion. You're supposed to listen to all the evidence, and it's deemed that you are not actually working for the person who's paying, you're actually working for the court. You're supposed to be completely impartial. Supposed to be. That's obviously a bit of a paradox, because I'll be paid by HSE as an expert in the court, and the defendant will have an expert as well. But that's their job description. And this has always existed. But since 2016, we got some new sentencing guidelines to court in 2016. And essentially what that does is that's giving the judge a prescription list. And it's meant that the fines people get for gas-related incidents has gone up massively. And if you're a big company and you get something wrong, you can incur a really, really large fine these days in a way that you didn't used to. And unfortunately for me, the upshot, that's a good thing, undoubtedly. But it means that companies and individuals are more likely to spend a few £1,000s involved getting a defence expert in to try and get that fine down, even when they're guilty. So that's the document that I'm talking about, the Health and Safety Offences, Corporate Manslaughter, Food Safety and Hygiene Offences Definitive Guideline. And it's a very dry document. I'm not going to speak about it very long, but these are the sorts of things. You'll see things that have gone wrong in the media, and you'll see the sorts of things that go through court or things that don't go through court and wonder why. One of the things I have to do as an expert is look at the incident and decide what the level of harm is. Now, somebody might have done something really stupid. They might have created an immediately dangerous situation, and it's undoubtedly immediately dangerous. But the likelihood of it actually murdering somebody is very slim. That would be called a level C. Or, if somebody has pulled a flue apart and left it emitting carbon monoxide into a room, I would argue, we know carbon monoxide kills people. The situation there was a level A. It's likely to cause death. You match that against the likelihood of that harm actually happening. So most gas incidents that I talk about tend to be level A because we know people die from gas explosions, carbon monoxide. but we mentioned to the level of harm that could likely occur. This is all opinion. Harm category 1, if it's high harm and level A, it comes to be a harm category 1. So that's part of my job, looking at that. The judge then looks at the turnover of the company and the harm category, and is told a level of fine that they might get. So this is for a micro company, as the document calls it. That's with a turnover of less than £2 million. So, you know, a single trader or a small company with 4 or 5 people that creates a harm category 1 with low culpability might get a fine between £18,000 and £60,000. So that exact same misdemeanour, if you're British Gas or you're Cadent, you might get fined £5 million because your turnover is much bigger than that. That's how it works. Now these sorts of fines, as I say, mean that defence experts pop out of the woodwork. I'm going to just tell you about one particular example. So we have a tower block in Stevenage, and a lady, most of the flats in this tower block belong to the council. Some of them have been sold off. And a lady on the 9th floor lives in her own flat. And she's been feeling unwell for quite a few days. She notices that her dog is really off as well, is listless, is being sick. Carbon monoxide alarm has gone off. So she calls out British Gas, who she has a home maintenance contract with, and the gas engineer goes to look at the boiler, and he thinks, what the hell? And you can't really tell from the photograph. These are the ones he submitted, but the boiler's essentially hanging off the wall. It's an old balanced flue Austin, I think, and it's hanging off the wall. So it's one of the ones that have got a sort of 12-inch steel cube flue outside, and there is no flue. The wall's been bricked up. So clearly very dangerous. The gas engineer made it safe, and he put a RIDDOR report into HSE. That's actually how most incidents come to us. And that RIDDOR says it's a immediately dangerous situation, carbon monoxide being emitted into the room, and I believe there's an explosion risk because that boiler is basically hanging off a 15 mil copper gas pipe. And I agree with it. So HSE is then going down the line towards prosecuting this company that's done some work, which I'll explain about now. So there's our tower block. I've said that the council owns some of the properties and some are not council owned. The council have decided that for their own efficiency reasons, they are going to take out all the gas appliances out of their flats and replace them with electric. So they appoint a contractor to do the building works, to take the flues out and brick them. They appoint a subcontractor. So scaffold goes up from this subcontractor. The floors of the scaffold don't match the floors of the flats. The floors of the scaffold aren't numbered, and an immigrant worker who can't read or speak English goes up without a map to take off the flat at our floor 7's flue and brick it up. And I might come back to that question earlier. If I said to you, sir, what's going to happen, you probably agree with me, it's quite foreseeable. There's a chance he's going to take the wrong one off, isn't he? And that's exactly what he did. He took off the flue of that working boiler in that lady's flat and bricked the wall. Now, HSE quite rightly said, well, that was ridiculous. It was a dangerous thing to do. It was foreseeable. You've not planned your work properly. You've not controlled your contractors. We're going to prosecute you. And a week before they went to court, a report from a defence expert landed. So this then bounces its way to me. Steve, will you have a look at this? Have we got our prosecution wrong? Is there anything we need to know about? Now, obviously, I've got my own opinions and my own bias, but I believe I've described the situation to you exactly as it was. And this report said the situation was completely safe. That boiler would flow into the cavity wall without any problem, and the combustion products would pass away. There's no risk. There was no risk of gas explosion because there wasn't a gas leak, and the CO alarm went off because the woman smoked. And so, no case to answer. Oh my God, what am I going to do with this? So you then have to write a report. But this particular, I'm not going to name him. I would have done if that wasn't my job. I've come across him a few times, and I've never quite worked out if he's incompetent.
Before both.
But then I have to write a report, and I try and explain, no, it can't flow into the cavity. It needs an air supply. The only reason it's got an air supply and able to burn is because it's hanging off the wall. That's the leakage route coming into the house. But what the judge is, bear in mind the judge, the jury are non-technical. So now they've got two experts telling them different things, and that's really confusing. And the judge doesn't like that. So then I have to go to a meeting with the defence expert, sit against each other and basically shout at each other until we get some agreed points, and he concedes that I'm right mostly. Doesn't always go that way, but that's kind of the process. Now, I think you'd agree with me that the things that he said are ludicrous, really, really ludicrous. But if we go back to that, this was a large company, and the judge is starting at figures like that. This is for a micro company, so it's starting at a really high figure. And for every little point of doubt that the defence expert can introduce, that figure goes down and down and down. So what happened was this building company got a fine. They'd already pleaded guilty, by the way. This is one thing that's true. They had pleaded guilty, but they went, well, yeah, but we're not as guilty as you say we are. That's once upon a time, somebody pled guilty, that was it. I didn't have any more work to do. Now I do. They got fined £640,000, which is a huge fine, but it could have been 1.2 million. So it was well worth that building company spending £20,000 on a defence expert to save them £50,000 or whatever. And that's kind of where we are now. And that's something HSE has to think very carefully about. It costs an awful lot of money to take somebody to court and prosecute them. And if we think that the person, you know, it's a one-off, it's not a serial criminal, or if we think that's going to be we've got the evidence, even if we'd like to prosecute them and it's clearly the right thing to do, sometimes we don't. And that's one of the reasons why people are looking in a very critical.
But even though there's a fine, surely because they're being prosecuted, that the public enforcement gets it.
Yeah, absolutely.
And the tender was looking into that.
Yeah.
Because it's easily accessible to that.
It does. You're absolutely right. When they're bidding for jobs, it's the sort of thing that contractors look for.
Well, I was entirely the building company. Surely the council would instigate the work. If they're taking gas out of the building and so that's off, presumably kept. Right. Wasn't it for them to highlight?
That is how the law works. Yeah, I don't know what they did about that, but ultimately, yeah, the person who initiates the work was on responsibility. They're supposed to look after their contractors.
Yeah.
Yeah. That's not a decision of mine. So yeah, again.
The defence expert to throw it towards the council out.
But it depends if you've got a principal contractor and then it's the design.
Yeah,
if the council has declined to appoint the principal contractor, which is the building company, then it's for the building company.
Yeah.
And then the client does have to carry out insurance.
Yeah, that's it. That's not part of the decision-making process about who we're going to prosecute and what the charges are is not me. That would be the general inspector. They come to me for technical advice. But I thought that would probably quite an interesting insight into this. You know, we're all gas people and we're interested in gas safety. But it's interesting to me that people aren't prepared to say such ludicrous things when we get towards court. So
how was that? An expert who is obviously how do they any qualification be considered to be an expert witness? Sorry, I was looking at
well,
it's not.
Yeah.
Yeah, we must not be able to demonstrate.
You have to be able to demonstrate. You have some examples, don't you?
So we're running country with the
Yeah, I'm sure we will. we might have approached 5 different experts, and all of them went on pace until somebody turned after it.
We know we're on HSE meetings until next Thursday. But I investigate fee going further, you know.
Yeah.
I had one client several years ago, for 180 main, maybe it's old restaurant, big restaurant, one classic contamination.
Yeah.
And they said to me, they wanted me to sign something up and say, can't say because it over pressurised it, probably to 32 bar and 16 bar net. But a main will take millions of samples that well above that, they're going to move back to a norm.
Yeah.
What's 16 bar? They will class it up. You got somebody to sign that off, somebody, some home engineer, some idiots.
It's disappointing,
You've
isn't it?
got them off 70 grand claim, that says, that's that contamination. I said, yeah, look at everything else you've done. And I mean, I did it. I didn't even charge for what I told them in the report. But
Yeah.
I didn't want to know why this was around 270 grand claim.
It's amazing, it's really disappointing. Anyway, guys, I hope that hasn't bored you too much.
It's very interesting.
Cheers, thank you very much. I think you agree with me there, absolutely fantastic presentation from Steve. Thank you very much. I'd gladly have you back every month. You just, it's on to basically what we do as a job. And I'm sure we've got more questions for you, but you've got more pressing
Anybody got any questions? I'm very happy to talk about them, but obviously.
Wrap it up there, but no, thank you very much, and brilliant speech. Thanks very much.